Hi, my name is Mahmudul Hassan Shishir, studying for BSc in Computer Science in North South University, Bangladesh. As you can see from the title of the presentation, I'll be talking about the Fibonacci number series. If you don't know what is Fibonacci number series, you will get a brief idea about it by the end of this video. However, if you already guessed, it is an increasing number series. So, what is Fibonacci number series? The Fibonacci number sequence or series is a set of numbers that starts with a 0 or a 1 followed by a 1 and proceeds based on the rule that each number is equal to the sum of the preceding two numbers. The Fibonacci sequence is named for the Leonardo Pisano, also known as Fibonacci, an Italian mathematician who lived from 1170 to 1250. Fibonacci used the arithmetic series to illustrate a problem based on a pair of breeding rabbits. If the Fibonacci sequence is denoted by f of n, where n is the first term in the sequence, the following equation obtained for n equal to 0, where the first two terms are defined as 0 and 1 by convention. As you can see here, the number 2 is found here by adding the previous two numbers respectively 1 and 1, and 3 is found by adding 1 and 2, and the rest are so on. You can see if we try to graph the Fibonacci number, we will find an odd looking infinity spiral. There are two types of approach to solve or generate this number series, followed by the general approach, also known as the naive approach, and another is dynamic approach or dynamic programming approach. At first, we'll look at the naive approach. One of the general approach can be solving the problem with recursion technique. In recursive technique, first we will declare base case for our program, which is 0 and 1, and then we will construct a recursive function to generate the rest of the numbers by adding the previous and the second previous numbers respectively. And it's a top-down approach, of course, as it starts from the top of the problem and goes to the bottom recursively. We will look at the simulation of this process. You can see in the first call was n equal to 5, which recursively called n equal to 4 and n equal to 3. And in the same manner, 2, 1 and 0. However, if you notice attentively, you will see the function recursively called for n equal to 3 and its rest of the tree is repeated twice in the program, which means the same problem are computed twice and the time. As you can see here, the height of the problem is n at the left side and half n in the right side. But since it is repeatedly solved, the problem since the problem is repeatedly solved, the time complexity increased exponentially to big O notation of 2 to the power n. As we have seen the naive approach so far and its problem with the overriding issues and the time complexity, now we will look at the dynamic approach. So you should be thinking, what is dynamic approach or dynamic programming approach? The dynamic programming is both a mathematical optimization method and a computational programming method. The method was developed by Richard Bellman in the 1950s and has found application in numerous fields from aerospace engineering to economics. Here by optimization, it means maximizing or minimizing the current problem in multiple subproblems or combining them. So how to solve a problem using dynamic programming approach? At first, we have to create a substructure for optimal solution. Then we have to recursively define the solution of that problem. Then compute the optimal solution using the bottom-up approach. Later, we will create an optimal overall solution for the computed data and compute the runtime of the program. According to the approach guideline we saw in the previous page, we have created a structure for the optimal solution, which is an array. Okay, first step done. Now we have created a recursive model of our problem. Now we will use a technique called memorization technique to get our optimal solution for the sub problems. So what is memorization technique in the dynamic programming? It's a top-down approach to solve any overriding problem where it stores the result of the sub problems to use the value for further use in other sub problems. As you can see from the definition, in this approach, memory is used to store the data, but as the values are stored and used multiple times, it saves the computational time. In memorizing approach, the first and second element of the array is set to 0 and 1 by default, and rest of the elements are set as -1. The function to generate Fibonacci number is Fibonacci number first check whether the element of the array is -1 or not. If it finds the value is not equal to -1, it returns the number to the array. Accordingly, if it finds the value of the array element -1, it runs a summation operation of the two previous array elements and return it to the array as a new element, or replace with the -1. If you look at the array, the element of the index 0 and 1 are set 0 and 1, and the rest are defined as -1. Now as the function finds the next element -1, it changed the value with the summation value of the previous two array element. Now look at the tree at Fibonacci of 2 which combines the 0 and 1 and got changed to 1. Now look at the Fibonacci 3 will be set using the value of Fibonacci 2, which previously stored in the array, and the predefined array element 1. Now Fibonacci 4 will replace the value -1 with the addition value of Fibonacci 2 and Fibonacci 3 from the existing array element, and in the same process the rest of the -1 will be replaced with the new values, and the repetitive elements won't be recalculated as they already stored in the array. Now since we have done computing the optimal solution, we now need to compute the runtime of our algorithm and compare it with the normal or naive approach, whether it is efficient or not. But first we need to know what is runtime. It is a theoretical classification or analysis which estimates and anticipates the increment of running time with per work done in the program. As you can see from the slide, the height of our problem is n, as we understood from the definition that the runtime consists of the total number of sub-problems and their execution time. We first calculate the total number of sub-problems, which is big O of n, and since every problem is solved only once, it is big O of 1. So total runtime is big O of n. Now another dynamic approach is iterative technique, which is a bottom-up approach. Soon we will understand why it is called a bottom-up approach. In this technique, an undefined array with null value will store the first and second element of the array as 0 and 1, and rest of the element will be null. A loop will be run from the third element of the array, where it will store the summation value of the previous two array element. So it stores the 0 and 1 in the index of 0 and 1, and later part in index 2 it adds the summation of index 0 and 1. In index 3 it adds the summation of index 1 and 2, which is 2. In index 4 it adds the summation of the index 2 and 3, which is 3. It keeps going on until the loops end. The loop ends where here mines stopped at index 6. Now what's the time complexity for this approach? Yes, you're right, it's also big O of n, which is far better than the time complexity of naive approach or general approach. I think we're at the end of our presentation. Thank you so much for being here and spending your valuable time with me. Thank you.